We are going to talk to you about JRuby today. We're going to talk about why JRuby might be interested. Before we get started, who is running JRuby for something today? Cool, maybe about a third of the room. So we're going to show you basically how to get up and going with JRuby, show you some of the reasons why it would be interesting for you to consider this to deploy Rails or other applications, and then hopefully draw you in so you'll try some stuff out. I'm Charles. And this is Tom. We are the JRuby guys now for 12, 13 years or so. We've been working on this, trying to make JRuby run well, make it do Ruby make it run Ruby well on top of the Java platform. Before we get going, one of our former contributors, Ola Bini, if you've heard of him before, he was one of the core folks back in 2006, 2007 that really helped us get Rails going. He wrote a whole bunch of the core libraries we still use today. And just because of his connections with Julian Assange and the fact he was living in Ecuador, he's been arrested illegally, he's being held for 90 days without a trial. It's a horrible situation. If you want to follow it, check out Free Ola Bini on Twitter. There's an account. We're trying to get some money together to help for his defense. Hopefully we can get him out of this Ecuadorian prison that he's trapped in. Horrible situation. And I'll let Tom take over.
Okay, I have a horribly large number of slides to get through. I have 24 minutes of slides, and this is going to happen in 20 minutes. So what is JRuby? It's a Ruby implementation first. You should be able to run any pure Ruby code, and it should just work. If it doesn't, file a bug, unless it uses something like fork, one of the few things that we can't support. We don't support native C extensions. We'll be talking about this quite a bit later in the talk. We're built on top of the Java platform, and so we get all the benefits and lack thereof that comes from that. There's tons and tons of tools. In this particular case, we're showing you some screenshots of Visual VM. You can see the GC going, so you can get a live view of that. But there's so many tools for the JVM that it's nice to look at the health of your application.
Right, this is just one of them, and it's free and built into a lot of stuff.
We have no global interpreter lock, which means that our native threads can easily saturate and use all your CPUs. That's a good thing. We'll be getting into this more later, too. There's a JVM or Java library for absolutely everything in the world. So if you're ever stuck because the RubyGem doesn't provide it, there's a Java library you can lean on. Today, that center line is JRuby 9.2. It supports Ruby 2.5 support. This is the only branch we're currently supporting. We had a JRuby 9.1 release, which was for 2.3. That's end of life now. We do have a Ruby 2.6 branch, but what we're wondering is can we skip putting that out and maybe put out Ruby 2.7 next? We did this once before for Ruby 2.4, and we didn't have any complaints, really. And the reason for this is we want to spend more time improving JRuby versus maintaining multiple releases.
Right. Bootstrapping a new Ruby compatibility level is a lot of extra work, so we might push it back to next year. Anybody here using 2.6 now or really eager to move to 2.6? That's kind of what we figured.
Okay. But if you want to check on our progress, this URL will be at the end of the talk as well. It shows you all the 2.6 features and what we have done.
Okay, so getting started with JRuby. Look like there's a good group of folks here that have not used it before. There's really not a whole lot to it. Of course, you can just go to the website. There's tarballs, zips, there's a Windows installer even. You can do it that way, unpack it, throw it into your path, and you're pretty much ready to go. But basically, all you need to do is have some JDK. We still recommend Java 8. Java 9 and higher have various security restrictions, and they're locking stuff down, so there's some warnings that might be printed out when you run on those. They work well, but it's just something to keep in mind. We're mainly testing on Java 8 right now. And then install JRuby through one of these mechanisms. The tarball, use your regular Ruby installer. There's an official Docker image out there that we're going to be taking management of as well. And that's really all there is to getting JRuby up and going. The only prerequisite really is having the JVM available, and then the usual ways to install it are all there. Here we're using RVM, so we switch to JRuby, we've got IRB. Here's a little bit of code that's actually calling into some of the core JVM classes. Just like you would call any piece of Ruby code, everything that's available at the JVM level is also available to Ruby. So it's a nice way to get access to those libraries. Now the next thing that you're probably going to notice as you start to use JRuby is that our startup time is not what we'd like. It's definitely an issue. Why is this a difficult problem for us? Why is this our perennial issue, really? Well, if you look at CRuby, everything in CRuby is already compiled native. So it boots up, and the parser is native, the compiler to instruction sequences, the internal interpreter, all of the core classes. Whereas on JRuby, all of those things are written in Java, written and compiled to JVM bytecode. So the JVM has to warm it up, has to decide what's hot, has to optimize it. So everything in JRuby ends up starting cold, from parsing all the way through execution. The JVM eventually does optimize this, and as we'll see in some of these benchmarks, it optimizes it very well, and we get a very fast Ruby, but it takes time, and you don't have that at startup. So the first 5-10 seconds, nothing is actually running as fast as it could be. As an example of how this is kind of the worst case scenario, here is, in the blue is CRuby, here's JRuby in the green. This is without any tweaks. If you just start running JRuby normally, 4, 5, 6 times slow for serious commands like listing gems or running rake tasks, and that's not what you want. As an example of how this really isn't our fault necessarily, the fact that we're on the JVM is the main issue. This is the same run of gem list, but run within the JVM, so it can warm up and so all of that code can get hot, and it gets down basically to where CRuby is. So we're looking at various ways to improve this and jump closer to the end of this when we start up, but right now it's a bit of a problem. So there's 3 things that we're looking at right now to help improve this. The first thing you'll look at is the --dev flag. This turns off our internal JIT. It tweaks the JVM to not optimize as much, and this cuts off a good 30 to 40% of any major command. So that starts to get it into at least a comfortable range. And one thing to note about this, if you throw it into an environment variable, don't come to us and report terrible performance on a benchmark. We're just going to say, you know, like I do all the time, I run a benchmark, it runs terribly, it turns out I've got this flag turned on. So that's one downside to it. But it does make a big difference if you're running JRuby and startup time is driving you crazy. Take a look at this. Coming up with more JVM level features, OpenJDK from 9 and higher has a feature called class data sharing. And this basically lets us share all of that JRuby class information, all of our core code across JVM runs. So it's less to boot up, it gets going a little bit more quickly. This is starting to improve our startup situation there. To do this, there's a JRuby startup gem you can install. That comes with a generate app CDS, application class data sharing. You run that, and then we should pick it up and starting up faster. And we're going to add more tools and tricks into this JRuby startup gem to kind of fix things and speed it up. A more recent one I've been excited about, another JVM from IBM called OpenJ9 has this quick start feature. So all you have to do is pass these 2 flags to it, and not only will it share all of our core class information, but it'll actually share compiled code across runs. So as the application boots up, optimizes, gets warm, and saves off a native code, that native code can then be picked up by future runs. So that's getting us much closer to the end of that warm-up curve. We're going to be pushing on this a little bit more to see what we can do. If we look at where our best times are, like I say, it comes down from 5 to 6 times slower than CRuby to in the 3 to 4 times slower range. It's enough to be uncomfortable, but maybe not enough to be super annoying all the time. The next big thing that we are looking at doing, we've got newer features on the JVM side. They're looking at doing ahead-of-time compilation of JVM applications. So one of these projects that's been very popular recently is called GraalVM. The idea here is that we could compile the core of JRuby and have all of that run native right away, but then continue to optimize the Ruby code and still load your stuff at runtime. Hopefully this will get us closer to startup. If we look at some comparative numbers with the Truffle Ruby implementation, which is 100% GraalVM based, here's their just simple -E performance. That's certainly more like what we want. We want to get down closer to CRuby performance for starting up a simple command. But on their end, if you actually boot up Ruby code, it still ends up being a bit slower. We want to try and have both worlds together to improve startup time. So remember those if you start playing with JRuby, and you'll be a little bit happier with the dev process. A couple other tips for making a move to JRuby or starting with it. Don't mix gem paths. Sometimes the Ruby installers, you'll be able to share it across different versions of CRuby, different versions of MRI. It really just doesn't work so well because we have different platform gems. We have our own Nokogiri version, stuff like that. So usually this is be separated by your Ruby installer, but it's something to keep in mind. .Ruby version, if you're working with an existing Ruby application, it's not going to switch to JRuby that's compatible with Ruby 2.5.3, it's going to switch to CRuby. So you've got to keep in mind if you're switching back and forth or testing an application, it catches me constantly. Usually I just delete the file, but if you keep it in mind, you'll probably be all right. Finally, on the getting started here, if you need help, we have our GitHub project, of course. We are now monitoring 3 different chat rooms. I would love to try and get this down to 1, but this is the world we live in now. So we have our IRC channel, we have Gitter, and then we're also playing around with JRuby on the Matrix open source chat forum service. And there's a mailing list if you're into that. There's not a whole lot of traffic, but there are folks monitoring it. Okay. So now, JRuby on Rails. We got a little bit about why JRuby, what we're getting out of that. Let's talk about JRuby on Rails itself. So we've been working on this for a long time. Like I say, 13 years that we've been running Rails since one of the early 1.x versions. Last week we were at Ruby Kaigi in Fukuoka, Japan, and we actually had folks that come up to us and ask, are there people that run JRuby in production? And the answer to this is yes. There's lots and lots of companies out there, some running huge, like 100 machine clusters of JRuby doing this stuff. A lot of times JRuby is the last mile for scaling. They can't get CRuby to go any bigger without massive cost. They can make a move to JRuby and stay with Ruby and stick with it for a longer. Like we say, benefit from the JVM and the libraries and all of that. We honestly believe that this is the best way to scale Ruby and Rails applications. Ruby apps in general, but Rails in particular. At some point, any application is going to grow to this level where it needs more out of it. Looking at what kind of differences we have at the application level, it's fairly minimal. So this is based on kind of a plain generated application. We've got a couple different gems that are in there. We've got different database drivers, different backend for doing JavaScript stuff, things along those lines. The Spring preloader depends on forking, so that's not something we support at the moment. Minimal database configs. We've worked hard on this so that almost nothing has to change in here. But the JVM database libraries don't do Unix sockets, so you'll be switching to using a local port. And then finally, here is the Puma configurations, just kind of to show that if you're scaling JRuby up, it's not via processes or workers. You can just throw as many threads as you want at it, and we'll scale up across all the cores. We'll saturate the whole system.
So I just wanted to add one thing. That very first picture of the gem file, when you actually generate an app with JRuby and Rails, it generates the right gem file.
Right.
He was just showing you what the differences were.
Right. So if you're going to migrate, these are minor changes you need to make. But the standard generator does generate a JRuby specific app. Rails does support JRuby out of the box.
All right. So we'll just look at the current progress of how we support Rails. First one to look at is 5.2.3. As you can see, we're passing 4 nines. There's a couple weird items on here. Action cable doesn't actually run on 5.2.3, but if we look forward to Rails 6, we can see that there's 10 errors. So I'm not really sure what's wrong here, but we're looking forward on Rails 6 support for this. Railtie has also used fork until like last Friday, so Rails 6.0 RC2 will no longer use fork for testing and will actually have valid results. I've run it locally and we nearly pass everything in Rails ties. For the errors that we do have, they're typically really weird errors, like getting a floating point representation of a date and having a slightly different round. So we want to go and submit some PRs to get rid of some of these.
Yeah, a lot of these are just bad tests. They should be doing a within a range kind of match.
For the active record support, this is our results for running Rails 5.2. We have our own project called RecordJDBC. We're green because it's our own project, but we do have a bunch of excludes for tests. Again, some of these tests are pretty low value, like some date in 1540s is slightly different due to differences between Java date system and the Ruby date system. And actually, a lot of these aren't actually bugs at all. We test the PG-specific tests in Active Record because they provide good value for us, but 20% of them are just super specific to PG, and we don't care. If we look at Rails 6, again, we're doing quite well. There's a few more failures to work through.
A few more projects to work through.
Yeah. But you can see here that action cable has 10 errors. These 10 errors happen to be that the pub sub adapter for Postgres directly uses PG-specific APIs. We already sort of emulate PG a little bit in Active Record JDBC, so this should be pretty simple to fix, but we have to look at it. If we switch over to Active Record JDBC for 6 support, we're basically there. We have 40 excludes in PostgreSQL only, so we still have a little bit of work to do. Also, Sunday, version 60.rc1 was put out, so you should be able to just seamlessly try Rails 6 RC1 now. I want to do a little throw out to Daniel Ritz, Dr. Itz. He has been keeping us up to date on this project real time for Rails 6, and we really appreciate it that he did that. Goodbye, Daniel. All right, so let's change gears a little bit. Let's say that you have a JRuby Rails application, you want to move it to JRuby. I happen to be doing this right now. I'm trying to convert Discourse to JRuby so that it works. It's a massive application. It has over 520 files in the lock file, or gems in the lock file, 250,000 lines of code. And at this point, I had to work through approximately 5 gems that weren't supported by JRuby. And the app is working, except it's not displaying the forum posts. And it is not a Ruby problem. It loads gazillions of lines of JavaScript, and there's some JavaScript issue that I have to work through. But it's mostly working at this point. So let's use this as inspiration for working through your own application. So using JRuby, you should install the JRuby lint gem. You should cd into that directory and run it. Now what's going to happen is you're going to get a report. The first thing it's going to do is it's going to look at the gem file, and it's going to make suggestions when it knows that you have a potential problem gem. Like fast XOR is not supported on JRuby, but Exorcist is. It's a nice suggestion. Change it. And this data is actually sourced off of a wiki page. So if you are a JRuby user and you look at this and you see something you can add, please do. And you just have to update the table. The other thing it does is simple static analysis. So in this particular example, we're or equaling a time delta together. If this is happening through multiple threads at a time, you're going to be losing some time here. So you just need to audit each of these cases and make sure that there's not any atomic update issues associated with it. In most cases, it's not. It's usually initialization when the app is booting and it's happening in like a class body or something like that. We point out things we don't support, like fork, or things that no one should ever use, like each object. But at some point, when you go through this report, you have to just try doing a bundle install. And you may or may not actually run into a problem where we don't support an extension. So you have to come up with a strategy for this. In this case, you could use pry-debug-jruby as a gem instead, or maybe it's not that important to you, so you just put a platform thing on it to get rid of it. Another thing you could do is just write it in Ruby. We run Ruby pretty fast. Maybe this is acceptable. Although if it is a hot path, like it is in Discourse, then maybe you have to go back and use a native extension. This wasn't needed for Discourse at all, but there's a project called Foreign Function Interface. It allows you to bind to a shared library and call the functions or interact with the structs on it. The best part is you use a Ruby syntax to do this binding, and all the implementations support it. So here's just an idea of how this would work in code. So you make a module, you extend the library methods from FFI, Now this gives you FFI lib, which allows you to bind to the DLL, and then you'll just make a series of attached functions where you give it its name, its input parameters, its return type, and then you can just call it. So pretty cool. Another feature that we have is the ability to go and interact with Java classes and objects as if they are Ruby classes and objects, and you can just import a Java library. Typically, from making an extension equivalent, you'll just write a little bit of boilerplate, extra facade code to add like block syntax and things like that to make it feel just a little more Ruby-like. I'm working on porting Mini Racer, which is a very minimal set of V8 bindings. I found a library called J2V8, which has a bunch of C code that allows Java programmers to access that from Java, but now I'm scripting that Java as Ruby. And it works great. So here's an idea of how that looks. You have to go and load the library you want to use. Then you import the particular Java class you want. Here I'm calling a class method, storing that result into an instance variable. Then I'm just executing methods on it. And you'll notice that execute underscore script, in Java that would be execute capital script, but we have a whole bunch of convenience aliases so that you can make Java classes feel a bit more like Ruby. And the last strategy is to use our Java native extension API. It's an analog to C extensions in CRuby, but it's written in Java and it's our API. This will be the most work out of all the strategies, but it'll also probably give you the best performance. I've been casually porting OJ for some time now. It's a surprisingly large gem for parsing JSON. It's about 20,000 lines of C, but it does absolutely anything you could ever think of doing with JSON and about 20 or 30 more things that you haven't thought of. So it's super sophisticated. Here's just a taste of what this looks like. At the top, we have a Java annotation to specify that this Java class is the Ruby module OJ. And then we have this Java method called strict load, where we have another annotation that specifies that this is a module method. It has one required argument, and rest equals true means it can accept additional arguments. So arguably, porting gems when there's a mismatch is some level of pain. Fortunately, most of the common gems have already been ported over the years, and I guess the silver lining to this is once someone actually ports it and releases it, we all get it.
Right. And we definitely would love to support people that have a particular gem in mind they really want to use. Usually you can do like a line-for-line port of the C code, and then you've got it on JRuby. So, and then everybody can benefit. So we'd love to see that more. Okay, I'll slide over here. So then we've decided we're going to do a JRuby on Rails. We've done the migration. We've got this up and going. Most of the standard tools that you're used to will work. We recommend Puma as a server, which is the default Rails server, I believe. Most of the same deployment tools work. We do have additional options because we're on the JVM. You can deploy it as a single archive and then just run the archive, and that's your whole app. Or you can deploy it into a Java application server if you want to do that to yourself. But one thing to note here is that the JVM expects that it's going to be the sole application running on this server, and it's going to use as much memory as it possibly can, unless you tell it not to. I'll show you in a little bit. We run the benchmarks, and it kind of blows up to a large memory space. It doesn't necessarily need that. You can choke it down to a much smaller level. So what about scaling Rails out? So this is the classic problem on CRuby. There's been whole companies that have risen up and become very successful and then disappeared again, trying to get Rails and Ruby to scale well. The problem is having no concurrent threads on CRuby really limits what you can do. You can shut some amount of I/O and some amount of database off and kind of run things concurrently, but at some level, if you've got a CPU-bound application and it's not I/O-bound, you're going to run into this, and you're going to need to spin up another CRuby and another CRuby and another CRuby for as many concurrent operations as you really want to happen. And even with copy on write, as you see in some of the memory graphs we got later, you're going to waste a lot of resources. At the very least, you've got multiple Ruby runtimes, all with their own garbage collectors, all wasting CPU cycles on their own memory space. And that's not how garbage collection is most efficient. It's most efficient when it's one process with a large heap and everybody's working on that same heap. So we believe, of course, JRuby is the answer to this. We can run a single JRuby instance with multiple threads, and it's your entire site. And in fact, you can run two if you want. If you want some failover on a second process, we're still going to use less memory and still saturate the entire system. Single process with awesome garbage collectors, awesome JIT, it's just going to use resources better. Once you get to a certain scale. I'm not saying like one Ruby instance is going to be, one C Ruby instance will definitely be smaller, but once you get to 4 or 5, we win pretty clearly. So one user story that we like to talk about, we hear these stories all the time, but this is one that really stood out to us. So it's a very large Rails application. They had running on 40 extra large instances on EC2, so this is not a cheap setup. 40 workers per server to make this thing scale out for what they needed. They were getting about 100K to 150K requests per minute, 50 to 75 millisecond response times, which is fine. They wanted to at least maintain that, but try to improve it. They migrated the app to JRuby and then made other changes in their system to take advantage of native threads. That 40 extra larges went down to 10, so the 75% cost reduction on EC2 costs there. And it was actually faster. It was consistently well over 150,000 requests per second, better response times, better use of memory, obviously, because we've got one quarter as many machines as we had before. So these are the sort of stories that really show us that this is the way to scale large apps. What is it that we're trying to do here? So optimizing for straight line performance in Rails is very difficult. It's only in the past year or so that we've really seen JRuby start to shine and be significantly faster. We were always kind of about C Ruby performance, but now it's looking really good. For more information on this, Kokobun did his talk on the new C Ruby JIT and how that runs Rails, and we're all struggling with getting this Rails framework to optimize. It's a lot of code.
We know people can't travel in time because that was the last talk.
It was just in here, yes.
It'll be online.
Right, definitely check it out. Like I say, we ran a little bit slower or roughly the same until very recently. So we've been very excited to talk about this the past year. So my little benchmark, I've just been doing, the basic Rails framework, a very simple application. So this is just a scaffolded blog application, the standard scaffold generate that you can do. Running in more of a realistic scenario, we're running on a T2 extra large here. This is based on Postgres. I didn't mention this Postgres-based application. I didn't throw the Truffle Ruby numbers in here because they were really weird and they're still working on it. So C Ruby versus JRuby is what we're going to see on these slides. That bullet did not get updated, did it? What the hell, drivers? So we had lots of variability depending on how we run the benchmark, what server we use. Tom will talk a little bit more about that too, but we're still trying to figure out what are the exact right numbers. Generally, we seem to be faster, but we're trying to figure out those tools. And then we were running workers for C Ruby versus threads on JRuby, of course. So this is it. There's the reveal. Like I say, it's not a whole lot faster. This is not with a lot of tuning. This is really with no tuning at all. We haven't looked into anything, and we're already out of the box faster. Tom will show a little bit later that we can be faster like this and use a lot less memory, too. I mentioned the caveats about the benchmark driver, depending on whether we're using AB or work or siege or whatever. Numbers keep changing. They're all over the map. So there's something strange about the combination of those benchmark drivers and Puma that's giving us some odd results. Keep Alive doesn't seem to be working properly in Puma at all right now, so that's something we're going to work on this week, ideally. And then, of course, the warm-up time. So we give our benchmarks a little bit of time to warm the application up. Typically, users that deploy JRuby in production will run some number of common requests just to get things going a little bit. And I don't think that's too unusual. So what about a larger app? Well, Tom will walk you through something more significant here.
We decided to go and set up a real app, so we got rubygems.org. We didn't have many problems, or really any problems, getting it set up. All the changes for the application were pretty much changing it so that I could run in production mode on my laptop. The original plan was to run this on EC2, and we went into a benchmarking hell of sorts. Man, benchmarking's hard. Anyways, so I ran it on my laptop. It's an i7 with 16 gigs. It's a reasonably spec machine. I disabled HTTPS because I didn't want a self-signed certificate. Difference between C Ruby and JRuby with HTTPS isn't really different. We use Puma on both implementations for an apple-to-apple comparison, and JRuby doesn't run Unicorn. And all this stuff is running on the same machine. In a way, this ended up being a good thing because we want to saturate the CPU to show how we can overutilize a machine. And we ended up using Apache Bench in the end. I just went backwards. There we go. I don't even know why I'm hitting the arrow keys. So when I first got the application going, I set up a user for myself, and I was going to push a gem, and then I decided, oh, I should benchmark this quick. And then I went down into some benchmarking hell, where I started using this tool called WRK, and every time I'd run it with additional threads, it would show absolutely no improvement. And then after about 4 or 5 days, someone's like, oh, it's an I/O reactor. You actually have a concurrency of 10. And then I'm like, screw that tool. And then I switched to AB, and then I was using Keep Alive. And then we discovered, hooray, Puma has a bug with Keep Alive. So if you want to see the details for that, go to bug 1565 on the Puma project. So we're only benchmarking accessing a profile. It has quite a bit of logic. The view is pretty sophisticated. So here's us running AB, doing a single synchronous request over and over again, where each connection closes. If we look at the yellow line first, this is CRuby running Puma in single mode, so there's 20 threads here, but it's only getting one request at a time, so it's very flat. If we actually look at Puma in clustered mode, this has 20 workers or 20 spawn forked subprocesses. You can actually see it's about 6 requests per second faster, and the reason for this, I believe, is that as the next request comes in, the previous worker is still closing the socket. So this is the overhead of closing your connection shown in graph form. If we look at the blue line, this is JRuby itself. You can see that it slowly gains in performance, and this is the JVM doing its thing, doing profiled optimizations and continually making it faster. By the 17th iteration, we actually catch up to CRuby. We'd like this curve to be a little more steep than it is today, but we did manage to catch it. But this is the much more interesting graph for us. In this case, along the x-axis is concurrency. So at concurrency 10, AB is sending 10 separate requests in parallel to the servers. On the y-axis is its peak requests per second that it ends up getting. So again, if we look at the yellow line, it kind of looks like it's level, but it's actually decreasing because a global interpreter lock and native threads don't mix. So it's not really getting any benefit there. If we shift up to the green line, this is Puma in clustered mode, and you see a nice curve as it scales out. It flattens out between 8 and 10 concurrent users because by that point, my laptop is on fire at 100%. But then if you shift to the blue line, you'll notice that we actually outperform CRuby quite a bit here. And that's because we're running in single mode with 20 threads instead of 20 subprocesses.
Yeah, there's a lot less wasted resources.
And so there's an added benefit here. I really wanted to push it over the edge until we started seeing failures. And we actually survive longer before we start to give up the ghost. The next interesting thing in running this benchmark, I just continuously kept running it. Each run was about 35 minutes long, and I tracked the memory. You can see on the green boxes that it took about 11 runs for JRuby to stabilize. CRuby has 20 workers, so 20 subprocesses. There's copy on write semantics for the subprocesses, but we're looking at the actual resident memory that it's using.
Right, you're still going to have a working set that's going to bloat that up.
You can see those percentages on top of the blue boxes. You can see that those percentages are going down. So I believe that MRI will eventually top out on memory, but I didn't want to run it that long. In general, at 20 workers, we're using about half the memory. Going back to Charlie's example with an extra large EC2 instance, we'd probably be running 40 threads so that memory gap would keep getting larger. So the takeaways here is that we use less memory And this is just because we're using threads versus entire subprocesses. Copy and write does definitely help JRuby, but having to duplicate the entire Ruby runtime and Rails stack and your application in each subprocess is going to take some extra memory, even with copy and write. We're more stable over time as well. I actually don't understand why JRuby was growing. I suspect it was just pages getting hit from updates on copy and write. It's possible there's some fragmentation in the GC, and the GC size is growing. I don't know. I highly doubt it's a memory leak. They're pretty stable. We're also more CPU efficient. Again, this largely comes down to us having threads and not having to have an entire runtime, an entire garbage collector going in each process. And as you saw, we didn't fall over as quickly either under load. So we have one minus, and that minus is that we'd like to see the warm-up time improve.
Right. And we're actively looking at that too, along with the startup stuff. Similar sort of problem. Okay, so wrapping up here. So future work for JRuby. We'd love to know what you think about 2.6 versus 2.7. I think at this point, we're probably going to be just doing 2.7. We've got a lot of the 2.6 work done, but if people are happy with 2.5 compatibility, we'll stick with that for the next 6 to 9 months. We're definitely interested in the native compiling of JRuby, both on the GraalVM and on other native compiling JVM stuff that's out there. Hopefully get us the startup time we're looking for. Ideally, we don't lose the warm-up, or we can fix the warm-up and still run fast too. So that's what we're looking at. And then there's a whole bunch of other upcoming stuff on the JVM side, like having real native fibers, so we're not using threads to do that, having a built-in foreign function interface for native libraries that the JIT knows about, and of course there's new JITs and new GCs all the time. We get the benefit of all this just by being there. Futures for JRuby on Rails. Like we showed, Rails 6 is working today. We actually expected we'd have to do a lot more work. But thanks to folks like Daniel and others out in the community, Rails 6 pretty much just worked out of the box.
I'm going to point at a guy there. He's going to be adding Rob. Sorry, Rob. Rob's putting out Microsoft SQL Server support pretty soon.
Right. So if anybody still needs that, we're getting that back into our stack too. And we're here when you need us. So we're not saying that you should immediately take your single server, single worker JRuby app and move over to JRuby. Maybe there's something you need out of us at that scale. The JVM itself, the libraries, the tooling, fit into an ecosystem. But as your app grows, pretty much everybody's going to get a benefit from this sort of migration at some point. It's going to get big enough that we're going to help you scale that stuff out. So you can start with JRuby on an app, but at least keep us in mind for the future. Think about what that migration might look like and let us know. We're willing to help you out with it. Hopefully we'll see some of you on here. This is a bunch of logos from current and past users of JRuby. We're thrilled to have folks up here like IBM's got their Watson Explorer data intelligence app that runs on JRuby. BBC runs all of their election results through a JRuby-based application. So there's tons of folks out there that are using JRuby in big, important settings like that. Maybe you'll be up here soon too. Finally, help wanted. Rails tests are a great opportunity. Just run the test suite. If you see something that looks like it might be fairly simple, like even if it's just a test fix on the Rails side, that's a great way to get involved. And we're always standing by on email, Twitter, Gitter, etc. to help out with stuff.
If you happen to support a Ruby gem, please go and try it and test with us and then report any problems you find.
Yeah, add us to your CI. Do it. So that's about it. Try JRuby. Let us know how it goes. I'm going to be hanging out here all week. I think Tom's going to be around too. So give it a shot. And that's all we have. Thank you.